Bismillahirrahmanirrahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to discuss a few questions from International A-Level Edexcel M1 Mechanics, and the topic is specifically Vectors in Mechanics, chapter number 3. So here we have a past paper handout. First of all, we have question number 3 of the handout, which is GCE M1 January 2011, question number 4. So the question says that a particle P of mass 2 kg is moving under the action of a constant force F newtons. The velocity of the particle is 2I minus 5j meter per second at time t is equal to 0. Okay, so this is basically the initial velocity vector u. And it says that the particle has a velocity of 7I plus 10j meter per second at time t is equals to 5 seconds. So this is basically the final velocity vector at t is equals to 5. So the requirement of part A is to find the speed of the particle at time t is equal to 0. So as simple as that, you just need to find the magnitude of the velocity vector, magnitude of the initial velocity vector over here, because we need to find the initial speed. Okay, the speed when time t is equal to 0. So what we are going to do, we are going to just simply find the magnitude of the initial velocity vector. So magnitude of 2I minus 5j, which is supposed to be under root of 2 square plus minus 5 whole squared, meaning under root of 4 plus 25, which is under root of 29, and correct to three significant figures, this is 5.39 meter per second. Okay, so this is basically the answer of part A. So now in part B, we need to find the vector F in the form AI plus BJ. Okay, one thing which I like to mention over here is that as far as the questions based on forces as vectors are concerned, okay, when you are dealing with forces as vectors, so one part of this concept is basically covered in chapter number 3 of the textbook, meaning the chapter number 3, vectors in mechanics. All right, here you will deal with those questions which are based on the concept that the particle is under the action of a single force. Okay, in chapter number 3, you are going to deal with a single force only. All right, and as far as the chapter number 4 is concerned, which is dynamics of particle, as far as the chapter number 4 of the textbook is concerned, which is dynamics of particles, there you will deal with those questions which are dealing with multiple forces, meaning F1, F2, F3, F4, and so on. Okay, so when you deal with multiple forces, there you use the concept of the resultant force. Okay, so basically the resultant force concept is introduced to you in chapter number 4. Right now we are dealing with a past paper handout of chapter number 3 specifically. So here in this handout, in this past paper handout, I've only given those questions which are based on chapter number 3 concept, which is the single force. Particle is under the action of a single force. Okay, when you are dealing with multiple forces, then you will study the concept of the resultant force over there. Okay, in both cases, you are applying the Newton's second law of motion, which is force is equals to mass times acceleration. So this was some just brief explanation of what you need to know. You should be aware of these things, because when you have completed chapter number 3 and you want to do the practice of past paper questions, so as far as the forces as vectors are concerned, so you will only attempt those questions when where you are specifically dealing with a single force, where the particle is under the action of a single force. Okay, you can right now avoid those questions which are dealing with multiple forces. But if you have completed chapter number 4 as well, so that's also perfect. But for the purpose of this past paper handout, I have only given those questions over here where the particle is under the action of a single force. The questions which are based on multiple forces, that handout will come in chapter number 4. Okay, so I'll just erase this thing. You can take a screenshot of this brief illustration. Okay, so I am recording this video on 13th of December 2025, and I don't know when the next time mechanics course outline will be changed or whatever will be updated. So this is basically, you know, at this point, the forces as vectors is distributed as like some concept is given in chapter number 3 and some of the concept is given in chapter number 4. So this brief explanation is applicable at this moment of time. All right, so as far as part B is concerned, so we need to find the vector F in the form AI plus BJ. Okay, so basically the concept is that force is equal to mass times acceleration, Newton's second law of motion. Okay, so we need to find the force vector. What we know is the mass of the object, okay, which is given to you in kg. Mass will be given in kg. If the mass is not given in kg, if the mass is given in grams, if the mass is given in tons or mass is given in grams, so you need to convert it into kg. We need to specifically find the acceleration vector first. And for that purpose, what we know the fact is that the initial velocity vector is given to us in the question. Okay. And the final velocity vector is given to us in the question, and time t is given to us. So we can find the acceleration vector by using this equation. V is equals to u plus at. Okay, so v is 7I plus 10j, and u, the initial velocity vector, is 2I minus 5j. All right, acceleration is unknown to us and time is 5 seconds. All right, so I'm going to say that 5a is equals to 7I minus 2I plus 10j plus 5j. Okay, so 5a is equals to 5I plus 15j, meaning the acceleration vector is 5I divided by 5 plus 15j divided by 5. So acceleration is equals to I plus 3j. This is the acceleration vector, I plus 3j meter per second square. And now we are going to use the Newton's second law of motion. Force is equals to mass times acceleration. So mass is given to you 2 kg. Okay, so 2 times this acceleration vector, meaning 2 is completely multiplied by I plus 3j. Okay, so force is equals to 2I plus 6j Newton. This is your answer. The unit of force is Newtons. All right. So this was part A and part B. So now let's move on to part C. And for part C, I'll bring the picture of the question on the next page. Okay. So the requirement of part C is to find the value of t when particle p is moving parallel to I vector. All right. So first thing first, what you need to understand is that, the velocity vector tells you the direction of motion of the particle. Okay, in which particular path the particle is moving. So the velocity vector tells you the direction of motion. But in this question, the velocity is not constant. Okay, because when the velocity is constant, acceleration is zero. Agreed? And in this question, we have acceleration. And as we can see that the initial velocity vector is given to you and a final velocity vector is given to you. So velocity is basically changing with every value of t. As the value of t is going to increase, the velocity vector is going to change. The velocity is variable over here because acceleration is constant over here. Okay, so this means that, when t is equal to 0, so the initial velocity vector is like this, 2I minus 5j. Okay, this is the initial velocity vector. When t is equals to 5 seconds, so this is 7I plus 10j. So the velocity vector is like changing over the period of time. We need to find the instant, a particular instant, meaning we need to find a value of t when particle p is moving parallel to I, meaning the particle p is basically moving along the horizontal axis, meaning particle p is moving parallel to I. I is basically the vector which is having a magnitude of 1 in the horizontal axis. Okay, so we need to find the instant when the particle is moving parallel to I. So the concept is that, when one vector is parallel to another vector, so one vector is a scalar multiple of another vector. I'm going to say that the velocity vector is basically a scalar multiple of I. So let's say velocity vector is equals to Ki. And what we know the fact is that, the velocity vector is V is equals to U plus AT. Since we have successfully found the acceleration in part B as well, okay, we have found the acceleration and we have the initial velocity and t would be unknown. Okay, in terms of t, I'm going to get the final velocity vector. Okay, so I'm going to use v is equals to u plus at over here. So the initial velocity vector is 2I minus 5j. Okay, and plus acceleration times t, and the acceleration vector we have found I plus 3j meter per second is square, and t is basically unknown. Okay, so this will be equals to k times I. When one vector is parallel to another vector, okay, so we can say that the parallel vectors are scalar multiples of each other. So velocity is equals to k times I. So what I'm going to do is I'm going to take I as common, so multiplied by 2 plus t. Okay, I've taken I as common, and then taking j as common multiplied by minus 5 plus 3t. This is equals to ki. All right. Taking I common multiplied by 2 plus t and taking j as common multiplied by minus 5 plus 3t. So the particle is moving parallel to I, meaning the velocity vector is a scalar multiple of I. This essentially means that the j component is equal to 0. We can explicitly say that, you know, j component is equal to 0. So basically the j component will be equated with 0. This makes sense or not? Because particle is moving horizontally at this instant, meaning it is moving parallel to the I vector. Okay, so the j component will be equal to 0. So minus 5 plus 3t, meaning the coefficient of j will be equated with 0. Okay, minus 5 plus 3t is equal to 0. So 3t is equals to 5. So therefore t is equals to 5 over 3. This is supposed to be your answer. As simple as that. Okay. So j component is equated with 0 because the particle was moving parallel to the I vector. So we just need to find the value of t over here. Okay. This is the instant which we are looking for. Because the velocity is changing over the period of time, with every value of t, the velocity is changing. So we are just looking for one instant where the particle is, moving parallel to I. So this is supposed to be your answer. T is equals to 5 over 3. This was question number 3 of the handout, which is GCE M1 January 2011, question number 4. So now let's move on to the next question. So now moving on to the next question, we have question number 4 of the handout, which is GCE M1 June 2011, question number 7. All right. So the question says that two ships P and Q are moving with constant velocities. Ship P moves with velocity 2I minus 3j kilometer per hour, and ship Q moves with velocity 3I plus 4j kilometer per hour. So the requirement of part A is to find to the nearest degree the bearing on which ship Q is moving. Okay, so first thing first, we will just focus on part A over here. So I'll just bring the picture again with only part A, and then we will look at the next parts. So what's going to happen is that, you know, we need to find the bearing on which Q is moving. So basically, the velocity vector tells you the direction of motion. The velocity vector tells you the direction of motion. Okay. So ship Q is moving with a constant velocity of 3I plus 4J kilometer per hour. Meaning, let's say here is a starting point for ship Q. Okay. And 3I plus 4J kilometer per hour means horizontally we are going 3 units towards right and 4 units above. Okay, so the path of movement of this ship Q is like this. I'm going to make a straight line with a scale. Okay, so this is basically the direction of motion of ship Q. And what we need to find the bearing over here. Okay, so I'm going to make a north. I'm going to make a north on the starting point, and I need to find the bearing. So bearing will be measured clockwise from the north. Okay, up till the line of the direction of motion. So we just need to find the bearing. So let's say this angle over here, the acute angle from the horizontal, let's say I have marked this angle theta. So I'm going to say that tan theta is equals to opposite over adjacent, meaning 4 over 3. Now, in order to find the bearing, what I need to do, I need to subtract this angle theta from 90 degrees. Okay. So I'm going to say that in order to find the required bearing, we will subtract tan inverse 4 over 3 from 90 degrees. So 90 minus tan inverse 4 over 3. Okay, tan inverse 4 over 3. So what is the value of tan inverse 4 over 3? So this is 53.13. So 90 minus 53.13. This is supposed to be 36.87 degrees. Okay, and the bearing would be 37 degrees. So correct to the nearest degree, we need to write our answer. So as a three-figure number, 037 degrees. This is the bearing which is required, correct to the nearest degree. Okay, this is supposed to be our answer. A usual practice is to write the bearing as a three-figure number. Okay, sometimes if you forget to write as a three-figure number, if you just write 37 degrees, that is also fine. But you should try to be consistent with the usual mathematical approaches. Okay, so this was the requirement of part A. Alternatively, what you can do is you can find this angle theta as well. If you mark this angle theta, so you know opposite side will be 3 and adjacent will be 4. So you can just find the value of tan inverse 3 over 4. That is also fine. Okay, so tan inverse 3 over 4 is 36.87. So that is going to be your answer. So that approach is also perfectly fine. All right. So this was the requirement of part A. So now let's move on to the next part. So coming on to part B, we have a story over here. All right. So what's happening is that at 2 p.m. at 2 p.m. ship P is at the point with position vector I plus j kilometer. Okay. This is the R naught of ship P because 2 p.m. is basically the initial point, meaning the initial time, okay, after which we are considering the journey of the particles. Okay, so at 2 p.m. ship P is at the point with position vector I plus j kilometer, and ship Q is at the point with position vector minus 2j kilometer. At time t hours after 2 p.m., the position vector of P is small p kilometer, and the position vector of Q is small q kilometer. So in part B, we need to write down the expressions in terms of t for P, Q, and the PQ vector. So P is basically the position vector of ship P, and Q is basically the position vector of ship Q. And in order to find PQ, we are going to use the vector subtraction law OQ minus OP. As simple as that. So here we have the R naught of ship P, and here we have the R naught of ship Q. So R is equals to R naught plus VT, where R naught is basically the initial position vector, and the constant velocity vectors we already know from the information above. Okay, so as far as ship P is concerned, first I'm attempting part B, part 1. So basically the position vector of ship P is small p. Okay, so according to the you know terms used in the question, I'm going to write this R as specifically P, okay, which essentially means the position vector of ship P, and R naught of ship P, the initial position vector is I plus J, and the constant velocity vector for ship P is 2I minus 3J. Okay, so if you just leave your answer in this form, it is also perfectly fine. Otherwise, you can just do one more step, which is usually helpful for the further parts, that you see the I components and J components. So I can say that taking I is common, multiply by 1 plus 2t, okay, and taking J as common, multiplied by 1 minus 3t. Okay, so this is basically the small p vector. This is supposed to be your answer to part B, part 1. The I component is 1 plus 2t, and the j component is 1 minus 3t. And as far as part 2 is concerned, so again the same equation, r is equals to r naught plus pt. So small q is basically the position vector of ship q at any value of t. So r is replaced with a small q. Okay, and the initial position vector of ship q is over here, minus 2j kilometer. So r naught of ship q is minus 2j. Okay, and then the constant velocity vector of ship Q is basically 3I plus 4j kilometer per hour. So 3I plus 4j times t. Okay, so therefore I can say that Q is equals to, the I component is only 3t. So 3t is basically the I component, and taking j as common, multiplied by minus 2 plus 4t. So this is the answer for part B. Part B, part 2. So now coming on to part 3, we need to find the PQ vector, the displacement vector from P to Q. So according to vector subtraction law, we can say OQ minus OP, because these two vectors in part B, part 1 and part 2, these are the position vectors of P and Q respectively. Okay, so we are going to find the displacement vector PQ, or you can say the direction vector of PQ. Okay, so according to the vector subtraction law, PQ means OQ minus OP. All right. So what we can do the working in column vector form as well. Okay. So it's more comfortable to do the working in column vector. Sometimes I feel more comfortable in working throughout with IJ, but I'm going to give my answer in terms of I and J, as I have mentioned my answers in terms of I and J. Okay. But working we can do in column vectors as well. So 3t, and for ship Q, the J component is minus 2 plus 40. Okay, and then we subtract 1 plus 2t and 1 minus 3t. Okay, however, if the requirement of the question is to you know give your answers particularly in the form of I and J, so IJ notation is compulsory. Even though if the IJ notation is asked in the question as your answer, you can still do the workings in the form of column vectors. That is perfectly fine. Okay, so that's the thing. So uh, 3t minus 1 minus 2t, so positive t minus 1. This is the I component, and minus 2 minus 1 is minus 3, and 4t minus minus 3t means 4t plus 3t, which is 70. Okay, so therefore our answer PQ vector is, the I component is t minus 1, and the J component is 70 minus 3. All right. So this is the complete answer to part B, all three parts. T minus 1 is the I component. Okay. I forgot to mention this I. So now let's move on to part C. I'll bring the picture on the next page. Okay. So as far as part C is concerned, it says that find the time, find the time when Q is due north of P and Q is northwest of P. Okay. So first of all, what we have found a vector PQ over here. PQ in part B, part 2. So in part C, part 1, ship Q is due north of P, meaning ship Q is vertically upwards from point P. Because at point P, if we make a north, so Q will be vertically upwards. Okay, so I'm going to make a vertical line over here. This is basically the vector PQ which we have found, and Q is basically due north of P. Okay, and since we have found the PQ vector, what was the PQ vector? I'm going to write it again. The I component was T minus 1. Okay, I component was T minus 1, and the J component was minus 3 plus 70, or you can say 70 minus 3. 70 minus 3 was the J component. So as we can see that, ship Q is due north of ship P. So ship Q is vertically upwards from point P. Okay, so this essentially means that, the I component, the I component of this PQ vector, this will be 0. Makes sense? Because when we are moving from point P to point Q, okay, so we are just going in vertical path, right? Because the horizontal path, we are not going anywhere in horizontal path. So the horizontal path for PQ vector is 0. So I component will be equated with 0. We are just going to simply say that I component will be 0. As simple as that. Okay. So T minus 1 will be equated with 0, which means T is equals to 1. Or you can specifically say, since the requirement is find the time, so initially the time was 2 p.m. At 2 p.m. T was equal to 0. So after 1 hour, time would be 3 p.m. So either you can write your answer as T is equals to 1, or you can simply say 3 p.m. And since in the previous part we have found the vector PQ, so I've just simply used this vector PQ. Alternatively, what I can do is, if I just consider the position vector of Q and the position vector of P individually, which I have found in part B, part 1, and part 2. So I can just say that, the I components of P and Q will be same, which is also the same thing as saying that when you are considering the PQ vector, okay, in the PQ vector, I component will be 0, which means that in the vector OQ and OP, the I components will be the same. Okay, because when you consider the horizontal and the vertical axis, okay, so when the ship P and Q are like this, that ship Q is due north of P, obviously the x coordinates of both ships will be same. Okay, so alternatively, you can just equate the I component of P with the I component of Q, meaning 1 plus 2t will be equals to 3t. This will also give you the same thing. 1 plus 2t is equals to 3t. This is an alternative way to do this. 1 plus 2t is equals to 3t. So 1 is equals to 3t minus 2t, meaning t is equals to 1, or you can say 3 p.m. But since I have already found the vector PQ, so I am just using PQ vector. Okay. So this was basically just a quick alternative approach. In part C, part 2, the information is that find a time when Q is northwest of P. All right. So now when you are considering this thing that this is northwest, this essentially means that halfway between north and west. when we are saying northwest, so this means that halfway between north and west. Now here I need to give some detailed explanation. So just hold on with me. Okay. Halfway between north and west. All right. When we look at the compass, first of all, when we look at a compass, compass is like this. North is above, south is down, east is on the right, and west is on the left. So northwest means halfway between north and west, meaning the line of action over here is like halfway between the north and west. This line would act as an angle bisector of this complete angle. Okay, so this means that this angle would be 45 degrees and this angle would also be 45 degrees. Agreed with this? So this is the whole scenario which is going on over here. So I need to just give some detailed insight onto this concept. So first of all, what the fact is that when you consider the gradient of a line and the angle between the line and the horizontal, that is m is equals to tan theta. Okay, this is a concept which we have studied in pure maths, specifically in P1. Okay, as you can see that, if I just give you a review of this concept, all right, if you consider a line, let's say this is an upward sloping line, okay, and let's say this point A is x1 comma y1, and let's say this point B is x2 comma y2. Okay, so the gradient of the line has a formula: change in y coordinates divided by change in x coordinates, y2 minus y1 over x2 minus x1. So basically, if you consider a right angle triangle over here, so this opposite side is basically y2 minus y1, change in y coordinates, and this adjacent side is x2 minus x1. So you can say that tan theta is equals to opposite over adjacent, isn't it? And therefore you can say that tan theta is equals to y2 minus y1 divided by x2 minus x1. And in place of y2 minus y1 divided by x2 minus x1, we can simply write the gradient. So tan theta is equals to m. Therefore, m is equals to tan theta, where theta is basically the angle between the line and the horizontal axis, the positive horizontal axis. Okay. So this is basically the P1 concept, which is being applied over here. So what you need to understand is that, um, ship Q is basically, ship Q is northwest of P, meaning ship Q is halfway between north and west from point P. Okay. So here I can say that, the ship Q is, let's say, somewhere over here, and ship P is, let's say, somewhere over here, and here is the PQ vector. Okay. And let's say we make a north at point P. So this shows you that, ship Q is northwest of P. Ship Q is northwest of P, meaning halfway between north and west. Okay, so this essentially means that this angle over here is 45 degrees, which essentially means that the angle from the positive horizontal axis is 135 degrees, meaning 180 minus 45 degrees. Now, what you need to understand is that, if anyone sees this line, even though, the vector, the arrow of the vector is like going upwards, okay? But if anyone sees this line, what would they say? That this line is a downward sloping line. Agreed or not? Something, let's say something like this. Anyone would say that this line is a downward sloping line, and downward sloping line has a negative gradient. Make sense to you or not? Okay, so the gradient would be -1. How the gradient would be -1? Because gradient is equals to tan theta, and theta is basically the angle from the positive horizontal axis. So gradient is equals to tan 135. And as you already know the fact that tan is negative in the second quadrant, so tan 135 is -1. So this means that the gradient of this downward sloping line is -1. This makes sense to you or not? Okay. Now we have established that the gradient of this line is -1. And what we know the fact is that PQ vector, which we found, T-1 is the I component. Okay. For PQ vector, T-1 was the I component and J component was minus what? कहाँ गया यार? It was 7T minus 3. 7T minus 3. This was the J component. Okay. So now this vector is essentially giving you a way of having an expression for the gradient, because the gradient is basically the change in y over change in x. I can say that, you know, I can say that the gradient of this line is change in y over change in x. Okay. Meaning change in the vertical coordinates divided by change in the horizontal coordinates. Meaning change in the j component divided by change in the I component. Okay, so I'm going to say that the gradient is like this: 7t minus 3 divided by t minus 1, and the gradient is -1. How simple is that? इससे आसान कोई काम हो सकता है जिंदगी में? Is there anything else which can be more easier than this? Okay, 7t minus 3 divided by t minus 1 is equals to -1. So 7t minus 3 is equals to minus t plus 1, and then 7t plus t is equals to 1 plus 3, meaning t is equals to 4 divided by 8, t is equals to half. Or you can simply say 2:30 p.m. because when t was equal to 0, time was 2 p.m. So t is equals to half, or 2:30 p.m. is your answer. So this was basically the gradient approach. All right. So I'll just make you go through this whole thing again, and then I'll give some another explanation if you don't consider the gradient. Okay. I'll give an alternative explanation over here as well. So the requirement of the question was find the time when shape Q is northwest of P, which means halfway between north and west. Okay, halfway between north and west means that this line of action would act as an angle bisector of the angle between north and west. Since north and west are perpendicular to each other, so the gradient from this horizontal line is basically 45 degrees. So if I consider this whole obtuse angle in the relationship, gradient is equal to tan theta, which I established over here according to the P1 concepts. Okay, so obviously this line would have a gradient of -1 because m is equals to tan 135, gradient is -1. Anyone sees this line, they would say that this is a downward sloping line, not an upward sloping line. Okay, all right. So here I'm going to say that m is equals to tan theta, so gradient is -1, and basically the vector PQ is telling you a way of considering the gradient. Gradient is basically change in y over change in x. So when you are moving from point P to point Q, so basically you are considering the change in I component and the change in j component, isn't it? Makes sense. When you are considering the vector of PQ, so this is essentially telling you that in order to move from P to Q, what would be your change in x coordinates and what would be your change in y coordinates. Okay, the change in coordinates, change in I component is t minus 1 and change in j component is 7t minus 3. All right, so 7t minus 3 divided by t minus 1 is equals to -1. Therefore, t is equals to half, meaning 2:30 p.m. This makes sense. All right. Alternatively, if you don't consider the gradient, okay, let me tell you another explanation over here for this part C, part 2. Okay. Alternatively, if you don't consider the gradient, what you know the fact is that, you know, here is shape P, here is shape Q, and shape Q is basically northwest of Shippy, meaning halfway between north and west. Okay, so this essentially means that if you consider a right angle triangle over here, this right angle triangle would be an isosceles triangle. This makes sense or not? Tell me. Okay, this would be an isosceles triangle because this angle is 45 degree. Obviously this angle would also be 45 degree. Okay, and this would be 90 degrees. So let's say, you know, this point is basically, if you consider the x-axis and the y-axis. Okay, so let's say this point is -2 comma 2. Okay, when you are considering the axis, x-axis and y-axis respectively. So you know the change in x coordinate is like this towards the left. So x coordinate is -2, y coordinate is 2. The magnitude of the coordinates is basically the same, but I would say that this point is -2 comma 2. Okay, and let's say this point is origin. So anyone would say that the gradient of this line is -1 because this is a downward sloping line. So what would you say that 2 and -2 are not equal, right? 2 and -2 are not equal, but if you need to equate -2 with something, so -2 will be equals to minus sign multiplied by 2. Or you can say 2 is equals to minus sign multiplied by -2. This makes sense or not? So basically, if you don't consider the gradient, fine, no worries with that. But if you do this alternative approach, so here according to this question, here we have point P, here we have point Q. Okay, and we are going like this. This is an isosceles triangle. This angle is 45 degree, and obviously this angle is also 45 degrees. So if you consider the vector, so t minus 1 is towards left and 7t minus 3 is upwards. So if I want to equate both of them, if I want to equate I and j both with each other, obviously I have to adjust with a minus sign as well. Okay, right now I cannot say that t minus 1 is equals to 7t minus 3. Right now they are not equal to each other. You have to adjust a minus sign. So you can simply say that minus sign can be multiplied on either side. So I have to say that, t minus 1 is equals to minus sign is multiplied by 7t minus 3. As we can see that -2 is not equal to 2. But to make them equal, you have to adjust a minus sign on either side, right? Like this way, -2 is equals to minus sign multiplied by 2. 2 is equals to minus sign multiplied by -2. Here is a very rough example, okay? I have chosen a coordinate -2 comma 2. You can say -1 comma 1. No worries. I just need to tell you that this is an isosceles triangle. I'm trying to explain this thing, okay? So without considering the gradient, you just saw that, t minus 1 cannot be simply equated with 7t minus 3 unless a minus sign is adjusted on either side. Okay, I hope this makes sense. And when you solve this equation, you will get t is equals to half. So t minus 1 is equals to minus 7t plus 3. So therefore, t plus 7t is equals to 3 plus 1. So therefore, t is equals to 4 divided by 8. T is equals to half, or you can simply say 2:30 p.m. So this was basically an alternative illustration. I believe, I hope I have given enough detail for this part C, part 2. Okay. If you don't understand this thing, you can rewatch it. Okay. I have explained both of the approaches. The best way is to consider the gradients. Okay. But if you're not considering the gradient, you should be sound enough with these basic mathematical, you know, concepts. All right. So best way, I'm comfortable with the gradient approach always. So I highly recommend that approach. Okay. So even if you still do not understand, you can leave me a message on my WhatsApp. I'll reply to you as soon as I can. Okay. So for the purpose of this video, I have discuss two questions. Okay, this was question number 4 completed, and the earlier one was question number 3. All right, earlier one was question number 3, right? Yeah, this one. All right, so see you in my next video. Inshallah, I'll be uploading more videos, so stay tuned to my channel. Thanks for watching, and if you like my videos, do consider subscribing to my channel. I would be highly thankful. See you in my next video. Assalamu alaikum.